So, what happens to a substance in a chemical change? As you're going to remember, this chemical property is matter's ability to change. A chemical change produces a new substance with properties different from those of the original substance. Two types of chemical changes are when one or more new substances result from the change, and when two or more substances combine and form a new substance. These can be written: A produces B plus C, or D plus E produces F. Other types of chemical change are possible, but every chemical change involves the production of one or more new substances. Examples of chemical changes: when natural gas, or methane, which is CH4, combines with the oxygen in the air, O2, it forms two new substances, carbon dioxide and water vapor. When fuels like natural gas or wax, or when wood burns in air and combines with the oxygen in the air, this is called combustion. That is one type of an example of chemical change. Other examples are electrolysis, which is supplying electricity to substances; oxidation, oxygen reacting with substances and producing rust; and tarnishing, sulfur reacting with substances and producing tarnish. There's a nice table in your book that shows how these chemical changes, examples of the chemical change, and how they work. The law of conservation of mass. I can't pronounce this guy's name. I've tried it 3 times already. But he's the scientist that proved the law of conservation of mass or matter. He says that whenever there is a change, a chemical change or a physical change, the amount of mass or matter of the reactants is equal to the mass in the products. So imagine a log burning in a fireplace. When the logs finish burning, all that's left is a pile of ashes. Will other products form during this reaction? The law of conservation of mass says that there must, because the ashes are not going to equal the mass of the original log. As a matter of fact, carbon dioxide gas and water vapor are products of the reaction that escape into the air. Their masses are not measurable in the fireplace, but they are a product of the reaction, which proves or which supports the law of conservation of mass. I will do a demonstration showing the law of conservation of mass during this class period. How are changes in energy and matter related? The definition of energy is the ability to do work or cause change. For a review, I hope you remember that kinetic energy is the energy of motion, and potential energy is stored energy. A lot of times we called it the energy of position, but we're going to find that potential energy can exist in other forms. The key concept in this section is every chemical and physical change in matter includes a change in energy. And another thing that I want you to remember is that heat and light are forms of energy. Temperature and thermal energy. Temperature is a measure of the average kinetic energy of molecules in a substance. Remember, we said that kinetic energy is the energy of motion? We know that warmer molecules move faster, so they have more kinetic energy. Colder molecules move slower and have slow kinetic energy, or less kinetic energy. Thermal energy, in contrast to temperature, is the total kinetic energy of all the molecules in a substance. Total of all the molecules. So a glacier could have more thermal energy than a teacup of hot tea because it has molecules that are moving slowly, but think of how many molecules are in a glacier compared to the faster moving molecules in a teacup of hot water. Thermal energy always goes from warmer substances to colder substances. When faster moving molecules, hot molecules, come in contact or touch slower moving molecules, the cold molecules, the faster molecules slow down because they transfer their energy by bumping into the slower molecules. Think of a pool table and the pool balls. When you hit the pool ball and it strikes another ball just sitting on the pool table, the cue ball transfers its energy to that ball and the cue ball slows down while the still ball starts moving. So just remember, when fast molecules, hot, touch cold molecules, cold, the hot molecules slow down and the cold molecules move faster. So the heat moves from the hotter object, or the higher temperature object, to the lower temperature object. We'll discuss the differences between heat, temperature, and thermal energy in a future chapter. For now, you will have to know how thermal energy is involved in physical and chemical changes of matter. Thermal energy and changes in matter. We know that kinetic energy is the energy of motion. Do you remember what the other kind of energy is? It's called potential energy. Chemical energy is energy found in chemical bonds in molecules. When the chemical bonds in molecules break, energy is necessary to make this occur. Also, when chemical bonds form between atoms, energy is released. Breaking the chemical bonds of molecules requires energy, and the forming of new bonds in molecules releases energy. Remember I said earlier that some atoms are happier when they form molecules? The molecules that break apart are called reactants. The molecules that form are called products. When the energy needed to break apart the molecules in a chemical reaction, in the reactants, requires more energy than the energy produced when the new product molecules come together, the resulting reaction absorbs energy, or is called endothermic. The temperature surrounding the reaction will go down because the reaction is using more energy from the surrounding air than it is being released by the production of the new substances. When the energy needed to break apart molecules in the reactants requires less energy than the energy released in making the new product molecules, the resulting reaction releases energy, or is called exothermic. The temperature surrounding the reaction will increase because the reaction is producing more energy by forming the molecules in the product than what was needed to break apart the bonds of the reactant. I would like you to do the math on page 27 in your books. We'll also do the quick lab, where was the energy? In the quick lab, you will have to follow all the safety procedures. You're going to need goggles, an apron, and keep your hair and all your clothing confined. You're going to add 20 milliliters of water to an empty can. You're going to measure the temperature of the water in degrees Celsius. Record this temperature on your paper under Procedure 1. Bend a paper clip and stick it straight in the clay stuck to the pie pan. Place a marshmallow on the flat surface of the paper clip. Light the marshmallow with a match while holding the soda can about 2 centimeters from the marshmallow until the flaming marshmallow goes out. Then again measure the temperature of the water in the can and record this measurement in degrees Celsius under the Procedure 5.